I'm Dr. Lutz Mary, Associate Professor in the Department of Computer Science and Engineering. I'm going to take the topic OpenStack for the subject cloud computing. So, OpenStack is a cloud software. So, OpenStack, the mission of the OpenStack is to produce the ubiquitous open source cloud computing platform that will meet the needs of public and private cloud providers regardless of the size. The scalability may vary by being simple to implement and massively scalable. So the founding principle is the open design process, and they have submitted the open source code repository, the open community, the process document, and transparent commitment to drive and adapt to open standard. So it has the open development, has the open design process, open community process, open standards, and modular design. These are the founding principles of OpenStack. So what is OpenStack? OpenStack is developing a cloud computing fabric controller, a component of infrastructure as a service that is called Nova. The architecture for Nova is built on the concept of shared nothing and message passing information exchange. Most communication in Nova is facilitated by message queues to prevent blocking components. So while waiting for the response from others, therefore objects are introduced. OpenStack has a flexibility to use multiple hypervisor environment in the same setup. That is, we could configure different hypervisor like KVM and VMware virtual machine VMware in the OpenStack setup. The Nova Compute service will take care of triggering the suitable APIs for the hypervisor to manage the virtual machine cycle. So in this architecture, the API server receives HTTP request from Boto and converts the commands to API format, tone from the API format, forward the request to the cloud control. The cloud controller maintains the global state of the system, and this is one of the property of the distributed system, ensures authorization while interacting with the user manager via lightweight directory access protocol, that is LDAP. It interacts with the S3 service. Then it manages the nodes as well as storage workers through the queue. So Nova integrates networking components to manage private networks, public IP addressing, virtual private network connectivity, and firewalls. It includes the following types. It implements, manages address and virtual LAN. The routing node governs the network address translation. It converts a public IP to private IP and enforces firewall rules. Addressing node runs a dynamic host configuration protocol for private networks. Tunneling node provides VPN connectivity. So OpenStack Nova, it consists of OpenStack API, OpenStack scheduler and controller. It has the database. All the thing will be queued. Nova conductor, Nova console, and Nova compute can have the guest. So everything is connected through the Nova API interface. You can have multiple hypervisors. The entire cycle of the virtual machine is managed by the hypervisor. When the end user submit the instance creation API call to the Nova API service, the Nova API processes it and passes the request to the Nova Compute service. The Nova Compute service processes the Nova API call for the new instance creation and trigger the appropriate API request for the virtual machine creation. So for in the way the hypervisor can able to understand. For example, if we choose the KVM hypervisor for OpenStack setup, when the user submit the virtual machine creation request via OpenStack dashboard, the Nova API calls will get into the Nova API service. It passes the API to the Nova Compute service. It knows the API the underlying hypervisor will support. Nova Compute service. All the services in OpenStack have at least one API service that accept and respond to the calls, and it pre-processes them, passes the request and the appropriate process within the service. Nova Compute service has the Nova API service which listens and responds to the end user compute API call. The Nova API service take care of initiating most orchestration activity, such as provisioning new virtual machines. Metadata service. The metadata service delivers the instance specific data to the virtual machine instances. The instance specific data include host name, instant ID, secure socket hashing, and keys and so on. The virtual machine access the special IP address HTTP 169.254.169.254. So how the provisioning machine will look like? Software to provision virtual machine is a massive scale. Then software to reliable storage billions of objects. So compute, how it will look like, the REST based API. Then you can have the Linux horizontally massive scalable hypervisor. So standard hardware RAID is not required. Asynchronous eventually consistent communication takes place. Example, OpenStack will look like this. In the management, we can have 1 gigabytes, everything is in the form of petabytes, from terabytes to petabytes. So cloud controller, global state of the system, talks to the LDPA API. So OpenStack compute will diagrammatically will look like this. System components, API server, interface module for component and control request, designed to modular support modular API. Message queue, broker to handle interaction between services, currently based on RapidMQ. Metadata storage, ORM layer using SQL Alchemy. For data storage abstraction, you can have Postgres and MySQL. User manager, the current release OpenLDAP, you can have a Redis database. Scheduler determines the placement of new resource via the API modular architecture to allow for optimization. Thank you.